Matt's worked for over 30 years in nonprofits in a variety of ways, including in education, communications, business admin, and he's got a master's in sociology and equity studies in adult education. He's the co-author of 2 adult textbooks and the PHIUS certified builder. Is that how you say it?
PHIUS is the acronym,
Yes.
yep.
Yeah, so he has co-founded a popular education co-op in Toronto. He was part of the community-based research team with me, exploring social determinants of health. He's been a senior staff member at Rabble for many years, and he has co-founded the Fourth Pig, where he's operations and education director. So very impressive bio, and I'm really looking forward to your talk. So I ask, if people have questions, can you please put them in the chat, and we'll gather them up, and then Matt can take them when he's ready. And
Yeah, I mean, I sorry, go ahead.
And we'll facilitate a Q&A at the end, but go ahead, Matt, please.
Yeah, I mean, I'm just going to kind of go through a bit of a dog and pony show and then answer any and all questions I can. This is us, Fourth Pig, Green and Natural Construction. So this is us in 2007. There's 4 of us that got together and we're like, buildings suck. They're unhealthy and they're ungood. And I'm going to talk a little bit about that. But we wanted to create an organization that reflected our values and reflected what we were trying to do. So we ended up starting a co-op, but the name, the Fourth Pig, comes from the story of the 3 little pigs who were hiding from the wolf, and one built with, sticks, and one built with straw, but they did a really bad job because sticks and straw are great building products. And then the last one built with bricks and it was freezing cold. So we the Fourth Pig knows what she's doing. It's going to be beautiful and warm, and there might have been some wine involved when we came up with that name. But we also were really looking at the source of energy for buildings. And so in our original iteration, we were really doing a lot of solar. I'm getting some feedback. Are other people okay with the sound?
Okay.
For me,
it sounds fine here.
There is a tiny bit of an echo, but it's not a big issue.
Okay.
Can everyone, everyone except Matt, please mute for this?
That might do it. Bruce, next slide, please. So we're a co-op. We wanted to have an organization. If we were saying we want people to build differently, then we wanted to build an organization differently. So we're a co-op. Next slide, please. So most people are probably familiar with co-ops, but the essential thing is that it's member owned, and people either use a service that the co-op provides and or they're a worker at the co-op, and we are a worker co-op. Just to make things even more fun, we're actually a not-for-profit worker co-op. We're the only not-for-profit worker construction co-op, we think, in the United States and Canada. And people are familiar with credit unions and co-ops, et cetera. But next slide, please. I realize I have something that might be slowing us down. So we're a mission-based organization, and you can see our mission there. And that's where we talked about energy production, because when we started, there was a lot of action happening around solar, and we were trying to just sort of tie that in, and we'll swing back around to that later. Next slide, please. So we belong to a number of organizations that reflect our values. Passive Buildings Canada, Ontario National Building Coalition, some co-ops, and there's many organizations in the world that are trying to really focus on green building, and so this is just some very quick background. So next slide 2, please. So I'm going to talk. So that was the Fourth Pig. I'm going to talk a little bit about the problem and how green building can and what green building is and what I think it isn't, and how we can do it better. And then I'm going to finish with some really, I think, valuable suggestions from some colleagues of mine about what can we all do. So some of this might not be news to anybody, but just going to start with the basics. So next slide, please. Um, our buildings are, I'm being nice here, are often bad. They're almost always bad for the health. They're almost always bad for the environment. And they're usually not prepared for the climate change that's coming. Next slide, please. None of this is new to you folks. This is from NASA, the rise of carbon dioxide in the atmosphere. And next slide, please. But when it comes in terms of building science and how this has an impact on us is when you've got warmer air holds more moisture holds more, and moisture is bad for buildings. And that could be the snow load, it could be the bulk rain load, it could be the just the ambient temperature. Years and years ago, people were like, oh, these beautiful 1700 or 1800 homes, they held up really well. Well, they held up because the moisture is able to get out because they're so drafty. But they were freezing to death. And then, people locked all these, they're like, oh, let's lock all the heat in. And they were locking the moisture in and things began to deteriorate. Lowell could speak at a much more expert level than I can, but that's the basic idea. So next slide, please. So you all probably know this, but this is Toronto's future weather. This is a study from 9 years ago. It's probably a little conservative, but we're looking at daily temperature maximums going to 44. We're looking at number of hot days tripling, extended heat waves, daily maximum rainfall. Look at that, going from 66, and then from 2040, which is really not that far away, to 166. And of course, if you built a building today, you'd expect it to be in operation in 2040. But people are building buildings right now, as we speak, that are not going to be able to, they're not designed to withstand this kind of stuff. Next slide, please. I just love this headline, but that's, yep. They're getting massive storms in Muskoka. In the fourth pig, we have sort of a Toronto office and a Muskoka office. So we're quite interested in what's happening up in Muskoka, and we're trying to really push up there to, people that are moving there to build more sustainably in that community. So next one, please. It's from the city of Toronto. Here they're talking about emissions. Very important distinction, but they're just talking about emissions. Different people count this in different ways, but 45% tends to be around where the United Nations counts buildings and their effects on greenhouse gases. They say around 40. So the essential truth is that if you don't deal with buildings, we're never going to meet our greenhouse gas targets. We know that. But here's the deep, dark, dirty secret. So the next slide. People, when they talk about energy efficiency, like all these slides before, like it's 45%, they're talking about emissions. They're talking about the operation of the building, the heating and cooling, the control of moisture. That's what they're talking about. They're not talking about the materials that went into the building, including in many, if not most, of so-called green standard buildings. So they don't talk about what's called embodied carbon or upfront carbon. It's getting a lot better, and I'll talk about that, but everything you put into a building, and concrete is a big one that a lot of people put in buildings, it requires a lot of energy to produce. And so if you're building a green building and you're going to save 50 tons of CO2 through your reduced emissions over the years, but you put 150 tons of CO2 in it to build it when you didn't need to, is it really a green building? So when we're looking at material choices or embodied or upfront carbon, you're looking at all these things: the pulling out of raw materials, transporting it, the manufacturing of it, moving it to the site, building it, and its end of life. What happens? And one of the important things about embodied carbon in materials is that it's an immediate savings that happens right now. So if I build a building using material that's lower in carbon, which is often a natural material, I'll get into this a bit more. Day one, I've saved X amount of carbon over whatever material I replaced that was higher. If I'm talking about emission savings, like these people are like, well, you'll save all this in your building over a lifespan of 50 years. Well, that takes 50 years to save that energy and is partially contingent on the behavior of the people in the building. And unfortunately, there's it's called, occupant behavior studies where people are in a building that's green and it's energy efficient. So they crank up the thermometer because they're like, well, I'm going to be comfortable. It's energy efficient. And of course, you end up in some cases with the same thing. So if you don't pay attention to the materials you put in the building, then it's very difficult to sort of say, well, this is necessarily a green building. Next slide, please. Fortunately, this is becoming more recognized. And just last year, the World Green Building Council began to sort of formally recognize this, bringing embodied carbon up front. So that's great because the researchers in Europe and some people here in Canada have been, and US are really pushing it, but a lot of the green building certification standards have not been pushing it, and it's extremely important. Next, please. Also, we're still in the negative part here. We'll get to the good part. Also, there's a lot of stuff that's put in our buildings that are never tested together. There's a chemical soup in the buildings, and you see this when you have these fires that are happening on the West Coast, and the toxicity of that smoke is phenomenal. And a lot of that's the foams that are burning in the buildings, and that could be everything from mattresses, of course, but to the insulation that's being used. And it's incredible. And only now are people really beginning to look at it, and this sort of obsession with energy efficiency at the expense of indoor air quality or chemical quality or embodied carbon is concerning. Next, please. Ooh, lost my screen. So this relates to, this is the red list. The Living Building Challenge is one of the higher building standards in the world, which is why there's only probably a dozen of these buildings. And I won't spend a lot of time on it, but it's worth looking up if you're really interested in buildings that are trying to actually benefit the environment they're in. Living Building Challenge, a true living, there's different levels of the Living Building Challenge, but a full Living Building Challenge building is net positive water, net positive energy. It has to have a community social aspect to it. So part of what they do is they create red lists of materials they recommend not using in buildings. And they've done some good research on all this. Almost certainly any building you're in, it's got some of this in it nowadays to some extent. So that's all the bad news. Next slide, please. Next, please. It's not that hard. It's just not that hard. This is the thing. We know what we're doing. It's been around for a long time. People have actually been building safely for millennia. But there's some new cool stuff. So my general formula, or the general formula, it's not my formula. Next, please. If you have an energy efficient building that has low upfront carbon materials, which is healthy materials, which are almost always the same, which are plant-based, and by that I mean wood or straw or clay or stone or lime, then you probably have a green building. It all depends. There's other factors. Apple likes to claim they have the greenest building on the planet, but they have literally 50,000 parking spaces outside of it because they built it outside of a downtown area. So is that really a green building? Maybe the building is, but so if we have energy efficiency and low upfront carbon and healthy materials, then how do we do that? So next, please. I'm going to look at a sort of more accessible energy efficiency standard than the Living Building Challenge, which is the next, please, the Passive House standard. I'm sorry, but I keep doing a lot of these quick ones, but one more. So Passive House is sort of a misnamed thing because it comes from the German Passive House, but it actually was partially inspired by the work that was done in Canada many years ago. But the reason it's called Passive House is because It can be heated, for example, without a furnace or often without any active heat forms, but it certainly has active systems in it. And so it gets confusing to people. But passive houses are being built all over the world, including in Toronto. Toronto Community Housing building a very large passive house right now. Um, and in terms of energy efficiency, it's very doable and very interesting. So I was going to quickly run through what makes a passive house. And one of the reasons is that when we think about building standards, people think about it as a destination, and it is a destination. If you want to get a passive house certified house, there's a bunch of stuff you have to do. But if you walk down that path of passive house, you could still have a super nice building. Maybe it's not like this epic building, but it's way better than what you'd normally get, and it's not that hard or that expensive. Next, please, Bruce. So the first big one is insulation. We all know about insulation. The key thing in terms of energy efficiency is reducing demand. The cheapest form of energy, it reduces demand. Yeah, Diane Sachs does a lot about passive houses. So yeah, the cheapest form of energy is no energy. And one of the easiest ways to reduce the need of energy is insulation. So when for a passive house, people are looking, insulation is rated by what's called an R value. And well, there's new codes here, but Lowell would know them more than I would off the top of my head. But a conventional home would probably, I mean, a passive house might have 2 or 3 times the R value of a conventional home. So a lot more. Number 2, next slide, please. Air tightness. And what we mean by this, I had a guy tell me once when I was explaining this to him, because the only thing I want airtight is my coffin. Air tightness doesn't mean that there's no way to breathe in a passive house building. It just means it's not super leaky. Most of our buildings are pretty leaky, and a little leak goes a long way. Like a little, like smaller than a hockey puck, like a toony leak. And I don't mean like a hole in your wall. I mean made up of all the little tiny things all over your house will result in a fair amount of air going through. And air going through is moisture going through. So a big part of passive house is making it what called super airtight. And that's using membranes like you'll see here in that picture that are designed to be airtight but vapor permeable. So the air stays in, the moisture goes in and out based on sort of the climate situation. But they're really trying to avoid hardly any leakage whatsoever. And it's measured through pressurizing and depressurizing the building and doing a test, either based on square footage or volume. Next, please. Not surprising, amazing windows are really important. And when people ask about the cost of green buildings, like, does it cost more? And the price is really, really, really coming down. But really great windows are still expensive. And that's just the way it is. They are coming down. But one thing you see here is a heat photo, a thermal photo. And the building in the middle, of course, is not put all that yellow and red and green, that's heat escaping. And the one in the middle, those are passive house windows. And you note very little is escaping there. Those with that thermal camera. Windows don't have a lot of insulation value. So yeah, I think it might be a house from Montreal. So, and they can of course provide energy and heat from the sun, and it can also be overheated, but you do need really good windows if you want to have a high performance building. Next, please. So contrary to popular belief, people say, well, in a passive house, you can't open your windows. You certainly can open your windows. You want fresh air, open your windows. But if you're in the middle of winter in Toronto, there are other ways to deal with it. And so there's often what's used is what's called an ERV, an energy recovery ventilator, or an HRV, a heat recovery ventilator. And these brings in fresh air, pushes out stale air. And an ERV can also exchange moisture. So maybe there's moisture it wants to keep because it's the winter, and it can grab some of the moistures in the house that's stale when it's leaving and grab the heat and the moisture, bring it back in and circulate it. And it's also filtered. A lot of people with the rise of COVID started talking about hygiene air. Can we have big buildings that filter the air so people that are large apartment complexes or other buildings that are sharing air uh, could have them filtered? Well, um, the passive house already does that. It already filters air. Is it filtering to that micron level, for COVID? I think the data is probably not complete on that, but it's certainly being filtered and cleaned. I'm not going to spend a lot of time on these things, but just trying to whip through them here. Next, please. Thermal bridging. This is a big one. So the whole idea is in an energy efficient building, you want to keep the heat you have that you want inside. And the picture here, which is not super clear, is they're showing a slab for an apartment building. And then outside that building are these often are like, decks or porches or just decorations. Well, that's just one slab. So heat is going to move from an area of high concentration to an area of low concentration. Like if you touch a cold pipe with your bare hand, that heat is pouring out of your hand. It's just like a highway for heat flowing out from on a single slab. So when they build passive house, they do what's called a thermal break. They put in materials that break the heat from moving from the inside to the outside. So these sort of corners or these slabs. People forget, they'll say, well, heat rises. Well, hot air rises, but heat just moves wherever it can. And so it's trying to move out and you want to stop it. Next, please. Oops. So that's the basic summary. Insulation's at least twice code, super airtight, triple glazed windows with insulated frames. Ventilation is just moving air in and out and using the heat from people, pets, and equipment, usually, and thermal bridging. And the passive house movement is really, really growing. It's done particularly well in BC, where they changed the code. And when you change the code, everybody's got to go. So they don't have a full passive house code, but they have massive incentives and there's build step code. And so Vancouver, they're building countless passive houses. Including many affordable housing and public housing buildings are passive house. In fact, I'm not sure there's any new ones that aren't paid for by the city of Vancouver. Next, please. Oh yeah, this is just me quickly showing that there's all these different people that are doing some pretty interesting stuff. And if you're looking for more information, and I've got some more at the end too, I won't get into it, but there's actually two passive house bodies, FIAS and another one called PHI, the Living Building Challenge. There's LEED that some people might have heard of. So there's stuff out there that a lot of good building science has gone into all this. Next, please. So now I'm going to swing back to that embodied carbon thing, because passive house is only focused on energy efficiency. And they're really good at it. And it's measured and it's objective when they do it. And Living Building Challenge is even better because they do a whole year of data of how the building performed with people in it. But passive house standard doesn't care how you get there. You could use insulation made of nothing but petroleum products, and people have been doing it for years. So it has can have a ton of embodied carbon in it and still be like, oh, this is a super green building. That's a position we reject at the Fourth Pig. We're like, well, it's not really a green building, is it? It's an energy efficient building, but it's not a green, sustainable building. However, you can also do passive house easily with all kinds of affordable and safe and healthy materials. So next, please. So those materials are often natural materials, as I mentioned earlier. Next. So this includes wood, straw, clay, earth, stone, lime, wool. Like when you go to Home Depot or whatever, and you get blown in cellulose, which is an excellent insulation. It's recycled newspaper, and it's super cheap and super efficient. So it's not; these aren't all. Some of these are rare and hard to do. Like wool insulation is popular in Europe and parts of the United States, but it's not. No one makes it here, so you have to pay for it. And there's still some products that need to come to Canada and a smaller market that you can get elsewhere. But next, please. The advantage of these materials is that they're actually well, sequestering implies that it's forever, but they're storing carbon for a very long period of time, which is what we need to do right now because we're in a climate emergency. We have to store it right now. It can be very local. We've built straw bale buildings a few times, including in Muskoka and in Toronto. And, the straw that we use is a byproduct farming. It's not like, even with wood sustainably harvested is a great building material, but it's still often harvested for building. No one plants straw to plant straw. They're planting hay and then using it, and then there's something's left over, which is sometimes burnt in the field. So if it can be used as a building material, then you are clearing out a field, eliminating something getting burnt, and storing carbon. Many of them have very much lower upfront energy costs, upfront embodied carbon. They meet or exceed building code, or we wouldn't use them. And they're generally not on the red list of chemicals. They're generally not been treated with something that is concerning. It's not always true. And there are some things that might have trace amounts of something, but as a general rule, people sometimes say, well, we're not sure exactly how much embodied carbon is in a straw bale versus in the styrofoam pad. Well, I don't need to know exactly. I know for a fact the straw bale is going to have less. Chris Magwood, who I'm going to mention, is from Endeavor Center, Builders for Climate Action. He says, you hear a lot of talk about, wouldn't it be amazing if we could invent some nanotechnology that stores carbon? He's like, we could. It's called a plant. And plants are great at this. And they're also great building materials. And people have been using them since time immemorial. So next slide, please. So this is just my little summary slide on this point before I get to other ones. Building green, as we define it, it's more energy efficient. It's actually more water efficient. You have higher indoor air quality because you have fewer chemicals. And if you're using a passive house, your air is filtered. So smoke, for example, and the fires out west, passive house people, their homes were performing very well in the smoke. General health and well-being because of a healthy environment. And the buildings last longer because of the moisture control that I was talking about than a lot of code buildings. And resilience, they're built for the storms that are coming and the weather that is coming. So next, please. So now I just want to finish by sharing. Oh, I forgot I had that one in here. Sorry. And the other side is your energy costs go down, your operating costs go down, the building depreciation rate goes down. There's low greenhouse gas emissions, probably lower illness, and lower embodied carbon. So next, please. I'm doing on time. I'm almost done. What can we do next? I'm going to steal some closing comments from Chris Magwood from the Endeavor Center, who I just mentioned, and they're in Peterborough. And then Ace McCarlton and Jacob Racusin from New Frameworks in Burlington, Vermont. And the Fourth Pig, we work with Chris a lot, and we've done a little bit of stuff with Jacob, and they were the keynote speakers on the Building Energy Boston 2019 conference last year. And you can find their whole hour-long presentation on how do we build more regeneratively. But I just love their final points. So I'm just stealing them, but they're credited here. So next, please. Number one, build with plants that build soil and rocks made from the sky, like carbon. Build with stuff that exists in carbon. Next, please. Fix what we have. There's a big focus on let's build these new buildings to passive house. Let's build a building living challenge. You can build every single building starting now at 8 o'clock, the best green building you can, and we're still going to have this problem because the vast majority of our stock obviously still exists, and we have to retrofit them. And the city of Toronto is coming out with retrofit standards, and we went to myself and some colleagues went to like a session where they're taking feedback from builders and architects, and we raised a concern that they weren't really addressing any mandatory evaluation of embodied carbon in these gigantic retrofit programs they want to do in Toronto. And I'm hoping, and I know that they consulted people like Chris Magwood. So I'm hoping they said it was draft, and we're hoping that it's going to come out with that. But if you're fixing what you have, it's a, it's an, it's a, 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 it's an it's a one-shot chance, right? Like the climate, we don't have a lot of time on the climate. If we're going to fix it, we better fix it right. Next, please. So focus on where materials come from and how we get them. This relates to what I was talking about with embodied carbon materials and how far they're traveling and how are they traveling and what's kind of energy was used to produce them. And it's complicated, but we have to think about it. Next. I didn't spend a lot of time on this, but you know, Ontario transitioned from coal fire to gas, which was really, really great. And now it needs to transition from gas to electric and to clean the grid. Because a huge portion of our energy comes from heating and cooling buildings. And if we can at least move that to electric and renewables, that's even if people have leaky homes, that'll help. Next, please. There's always this notion that something bright and shiny is over the corner. Oh, we're going to have, you know, solar panels that you can see through for your windows. And we probably will. And that's awesome. But we have stuff right now that's just fantastic. And some of it is very, very old ideas. And some of it, like the oldest straw bale buildings in the United States still standing, is a church in Nebraska from 1870. And of course, pursue what we can, but we don't have to wait. We know what we're doing right now. Next, please. We live in a world, and we see it all around us, that's largely influenced and controlled by developers and sort of a capitalist approach to buildings. And so it's very, very difficult to ask people to volunteer to do this. And so changing the code is the simplest way. Even though changing the code is very difficult, to force people. They did it in BC pretty well, and we can do it anywhere else that we have the political will to do it. And we need to educate everybody quickly about how important it is. But if we change the code, it makes it so everybody has to do it and lowers the price and makes it more accessible to low-income communities, and it makes it more accessible to developers. Next slide, please. We have to be able to count what we're really counting, like in terms of like climate change. And people, it's like, we're going to count carbon, and counting embodied carbon is difficult, and people are getting better at it, and new systems are coming out, including from our friends at Endeavor Center. But we have to be comparing apples to apples, and we have to be using real data to help guide our information on the choices we make in building. Next one, please. Almost there. This is kind of relates to the first one, but I love this. I love this point that they make here. We just can't be focused on building because we're trying to make a bunch of money on a development. Like, what does it mean to do these kinds of buildings in the context of community development? And what does it mean in the context of changing the world we're in? Like, how you can't just build a bunch of green buildings. And so there needs to be part of the conversation, and but it can't be just a green building thing, as I say, as a green builder. Next. This is important too. Like, you know, people are always trying to like conquer nature, and then we live to regret it. And then people go back and, you know, cities are finally realizing that flood control has a lot to do with re-greening spaces, and that you know, paving paradise, putting a parking lot on it causes you floods. So we need to really be paying attention to what we're doing beyond just where we're putting our buildings and how we're building them. Next, please. And this is the last one. I like this one. I don't know if right now during COVID, this is pre-COVID, I have abundant joy, but I have urgency and passion. And I think that's good to remind us. And then I think the next slide, I just have some resources. I think that's right. Oh, that's a summary, sorry, in the next slide of their points from Chris Magwood, Ace Marketing. And then, and these are just some resources. Passive Buildings Canada, where I also do some work, the Healthy Building Network, which is focused on sort of materials and stuff that goes in your buildings. Ontario Natural Building Coalition really promotes straw bale buildings and clay buildings and rammed earth buildings. Living Future Declare is part of the Living Building Challenge, but that's part of the Red List. The Embodied Carbon Network, self-explanatory, but they're from all over the world doing and supporting massive research on embodied carbon and its importance. And the Builders for Climate Action is a new organization started by the folks at Endeavor Center. I think next, please. I think that's it. Oh, that's it. There we go. Almost 30 minutes. We can, there's only a few of us here. Why don't we just have like a verbal conversation?
Thank you very much, Matt. That was fascinating. I really enjoyed it, learned a lot. So we have some questions in the chat, and then maybe people can explain their question. Like Matt said, we could do a verbal conversation. I think the first one, I just want to also welcome Sarah. Sarah, if you're there. Sarah runs Goldfinch Energy.
Sarah.
And Goldfinch Energy consults with people on how to map how to switch to greener technology in their homes.
Great.
Thanks, Arvia.
So I think, let's see, what's the first question? The first question is from Dawn. Dawn's been thinking a lot about finance and working on a deputation about finance. So his question is, can you compare the cost of construction? Do you want to add anything to that, Dawn?
I don't know exactly. I don't know the best way to compare current conventional construction to green construction. Is it possible to make a kind of cost per square foot to build, you know, sort of a 3-bedroom bungalow or something like that? Or I'm sure you were asked this question before.
Yeah, we get this question all the time, and we spent an hour and a half answering it. So I'll try to give you a short answer. First of all, comparing any two buildings, let's say two code-built buildings, and one's 2,000 square feet and one's 2,000 square feet, they kind of dramatically different prices. Like people say, what's it cost per square foot? And we say, well, what's your car cost per square foot? Or what's your shopping cart cost per square foot? Well, are you shopping at Whole Foods or are you shopping at Food Basics? Like what are you putting in there? And so the same size house with the same design can cost radically different amount of money based on the choices you've made. But I'm going to get to you. First, I'm putting in disclaimers here. So that's true. Now, a high performance house is going to cost more than a low performance house, regardless of how green it is. So a passive house is a high performance house. But a passive house made with green materials or natural materials can often be very close to competitive. The general number that's thrown around right now in North America is 5% I'm just talking about passive house here, because that's what I know most about. It's about 5 to 10%. However, some people, including a company in Nova Scotia called Passive Design Solutions, are building at market rate passive houses. Market rate is happening through a couple of ways. One is that people are doing more and more prefabrication. And in fact, the Fourth Pig has a relationship with a company called TEECC Prefab. There's a few companies doing prefabrication in Ontario. There's also one called Simple Life Homes. So they're prefabricating the wall assembly to the passive house standard, you know, in a warehouse somewhere, well, in a factory. And so it's weather independent. You know, it doesn't matter if it's raining or snowing, they're building your wall. So that's driving down costs. It's sort of like the way solar is coming down. Like in Vancouver, the prices of all these things are really coming down because everybody's doing it. So it's probably cheaper in Vancouver than it is in Ontario, Don. But so we tell people maybe 5 to 10%. This really took off in Europe because energy is so expensive in Europe. And your energy bill, and it really took off in the United States at first. A lot of it was being done with like Habitat for Humanity. Because if you've got people and you help them get into a home and they have some income challenges, and then Well, there's two payments when you have a house, right? There's a mortgage payment, which goes to a bank, and there's kind of like an energy mortgage payment that goes to your energy company. And maybe you've got an affordable rent or an affordable mortgage, but then winter comes around, you have a $300 bill. If you have a passive house, that bill is maybe $10 or $15, right? It's almost nothing. And so in Europe, your savings are enormous and people get sort of a return on investment very quickly. One of the challenges in Canada and the United States is energy is so deeply subsidized. Petroleum energy is so deeply subsidized that it is difficult because to make back on energy efficiency alone, there are many other advantages to building a sustainable house, not the least of which is it lasts longer and you have more functional space and it's quieter and healthier. But you probably won't make back that 5% in energy costs. You might make it back in resale value though, because the house is more sturdy or whatever. But again, another way to bring your prices down is to maybe go for mid-level finishes instead of top level. I mean, the thing that drives buildings up are bathrooms and kitchens. It's not your extra inch of insulation. You know, it's people they're like, I want a greenhouse. And then they say to us, oh, I want this fancy kitchen and this fancy bathroom. And they say, well, green buildings are expensive. Well, it wasn't the green building part that made that expensive. So it's a hard thing to answer, but the data seems to be 5 to 10% for a passive house.
Matt, you just answered it by saying there are only certain that the green portion of it only applies to certain materials, and they're not decorative.
Yeah, I mean, I mean, it gets a little more complicated than that, but because you want extra insulation and you're going to want better windows, which I said are definitely more expensive.
Yeah.
But there's a value to them too. For example, your functional space increases. Like if you've got a really leaky old window in the winter, you're probably not going to sit next to it. I've sat in Muskoka. I've sat in the windowsill, window, and just
focused on the cost.
Yeah.
Thank you.
And if you Google too, there's people that'll put up price comparisons and stuff.
Yeah, I know triple glazed windows are not cheap.
They're not. They're coming down, but they're not cheap.
Yeah. I couldn't find people who could even do them.
We use a place called Veta Windows a lot, and they're outside of Stratford, Ontario. They're not manufactured there. They're importing a lot of windows from Europe, but they were importing them on boats, which in some ways is better than importing them on a truck. And the way that they make it quasi accessible is they're just ordering huge amounts at once. And so like, if you want a window tomorrow, that's not going to happen. But if you're planning months in advance.
I just last reply, which is, that's really upsetting because we have lots of window manufacturers here. Manufacture of windows, even kind of a slightly different way of making them I can't imagine it's so exotic that the ability to do so is limited to a few places on Earth. You know,
That's not, and the two or three manufacturers now in Canada have passive house certified windows. At the Fourth Pig, our concern is only one of them has windows that are wood framed. They're vinyl framed. We won't use vinyl. But that's going to increase as the market increases, and it happened and they're in the West Coast because Vancouver is forcing it to happen. So it's happening. And it's just like solar prices coming down. The Canadian passive house windows in the market are definitely becoming more accessible every year.
You just reiterated a really crucial point in this whole process, which is kind of legislation and regulations that allow and encourage these things to happen.
No doubt. Yeah, somebody help me out here. Yeah, help me out.
Thank you. Yeah, sorry, I got muted. So Lowell has the next question, and then Sarah, and then Bruce. So Lowell, do you want to ask? It was about.
I hope you're not going to ask me that question that's in the chat, Lowell, because I would ask you because you're an architect. But go ahead.
No, I'm trying to understand. It's my, I guess I haven't talked enough with the science, building science experts, but you guys know just as much. And my question is, I always have the suspicion that the suburb homes are the ones that are super leaky, because the wood frame ones that are done like, since wood backup and with an airspace, and then at the most they would have 3.5 inch of brick, and it's that airspace and the fiberglass insulation that creates a convection current, right? And so all the heat is being lost because the moisture behind the brick, the thin brick veneer has to escape, so they have holes. And so that is that not like the most, like a lot more leaky than like your old a Victorian home downtown Toronto, which is like a 2 wide brick wall, solid brick. Is that not true?
My guess is what you're saying is true. To be clear, I'm not a building scientist. And in fact, I'm one of the least experienced people in building at the Fourth Pig. You got the scrub team today. But I've taken the passive house course. I passed it. I know a lot more than the average bear, but I'm not a building scientist. But yes, I agree. At some of these older Victorian buildings, first of all, they're double brick. So at least they have that. And some of them, they have some insulation of some sort. And then some of them have lath and plaster, and and they're still holding up because they are leaky, and those windows were bad. But yeah, the homes that were built in the 70s and 80s are travesty, a lot of them. And people think, well, they were built to code, but code does not mean a good building. Code means the lowest standard the law will allow for human habitation. That's what code means. Like the government's saying, don't put anything worse than this. And so that's code. Now, code's getting better over time, of course, but code is not, in my opinion, even now, if you build to code, I'd be interested to see how that building holds up in 40 years.
Well, they've been, upping the, every 6 to 8 years they would upgrade the code, and now they're, so like window areas is smaller for houses, like
Yep.
like condos, you can only do like 40% windows now. Since like 10 years ago, they changed, and so they are, making buildings. Insulation requirements are more for walls, but I just wanted to mention that in Vancouver, the climate is more moderate, right? It's more similar to like maybe
Similar to Germany.
It's more similar to Germany. So I don't know what's going on with like Ontario's passive house standards. Is there like a thing now in Ontario that it's like it should get certified? And because they were talking about it like 5 years ago, but I never followed. What is happening there? Because the weather is so cold here, right?
Yeah, you could certainly certify it in Ontario, and but first of all, Ontario is going backwards. We were going to have a system where homes would get a rating, like when it was sold, on how much energy you use, kind of like a nutritional label for buildings. And it's happening for very large buildings, but the Ford government came in and tanked that. The Liberals said for years they're going to do it. They finally said they're going to do it, and then it never happened. And then they got rid of the program where you'd get an energy audit, and then there'd be retrofits. Now the federal government says they're going to do stuff, but there's nothing from the government to go super passive housey. The city of Toronto's plan has got a lot of energy efficient standards in it that is allegedly rolling out. But as I said, it had no enforcement on embodied carbon when I saw it 2 months ago or 6 weeks ago. And I'm hoping that's going to change. But you can certainly build to passive house standards in Ontario, and people are doing it mostly through the PHUS standard, the PHUS standard.
Thank you so much. I think, Sarah, you had a question, right? Would you like me to read it out, or do you want to explain it?
Sure, I can say it. It's long, sorry. I mean, yeah, I find your point real. I agree that at least what I'm taking from your presentation is that embodied carbon matters as much, if not more, than thinking about air leakage, insulation, windows. And I guess, well, first I think it's exciting that there is more movement towards it. I'm sure you're more up to date than I am on the city of Vancouver and how they're moving towards capping carbon emissions from existing homes. And so I'm curious if there are apps or good resources to compare, basically if a homeowner is looking at insulating, and cellulose is a no-brainer in their attic, but then if they're thinking about insulating, in between their studs, if it's an empty cavity, it's like, okay, comparing options, the R value of spray foam is like 6 per inch, so it is twice as much as cellulose. So then, like, you can't, I don't know if it gets too complicated too quickly, but anyway, research support, like, to help people muddle through and make the best choices would be amazing.
So
This unicorn, I don't know.
the good news is the Endeavor Center, I think it's out, it's supposed to come out this month, are just releasing an embodied carbon calculator. And they've done a tremendous amount of work on it in order to make it way more accessible for consumers. There are embodied carbon calculators that are out for builders and architects, but they're really tough. I'm not sure how this works. They're not for profit. They may require membership to access it. I'm not sure how they're doing that, but if it's not out, it's coming out any moment. But they've done tremendous work on it. So there's that. Another general rule is, if it's a carbon-based material, it's got lower embodied carbon. So then the good question comes up, well, what about spray foam? And we're a spray foam free company. We won't use spray foam anymore. And I'll quickly touch on that. But if anybody wants, email me and I'll send you a little document we put together about why we don't use spray foam. And there's also a really good resource online from 475 Building Supply called The Problems with Spray Foam, and they have about 10 sections on it. Besides the fact that there's a lot of embodied carbon in it, but when I talk to people, some people are like, well, I don't really care. I'm like, well, the other thing is that it actually, its performance decreases quite significantly over time. And what the research we cite on that and the document that we share with people is from the Army Corps of Engineers. So this isn't like the Ontario Natural Builders Association, tree-hugging hippies like us. This is the Army Corps of Engineers, who are just trying to figure out what the aging of insulation is. And so they put a bunch of insulation in different rooms, pressurize them to sort of mimic aging. And the insulation that did worst was, polystyrene. Lost like 40% of its R value. And they said, because, it depends on these air capillaries, and those collapse. And once they've collapsed, it doesn't work. The other thing too, if anybody lives in termite area, is termites and ants love spray foam. The other one is it goes up like that. So it's got a lot of embodied carbon. Its R value decreases. You have to wear a hazmat suit when you put it on. So pro tip, it's probably not super healthy to be around. It's highly flammable. And it doesn't really work that well over time. Now, there's brand new spray foam coming out, which has a lower greenhouse gas emissions potential in it, GHG potential. Still suffers from the performance issues, and it has a flame retardant in it, which is, well, it's a proprietary secret, so we don't know. But if they're using the flame retardant that everybody else is using in these things, as far as I understand, they're using a flame retardant whose name is escaping me, but it's in the paper, which is ozone depleting. So yes, it's not GHG depleting problem, but it's an ozone problem. So I know I wouldn't use it. But that's my answer to people. They're like, we want to use spray foam. I wouldn't. I have in the past in my home. I regretted it. I then removed it. And then I read an article about how removing it is very bad for you. And even people wearing hazmat suits are showing effects from wearing it. So I now regret putting it in and the way I removed it. But you learn the hard way.
And then the new generation that they claim, sorry, it's even lower now. It's even lower, the insulation value than before.
Yeah.
Sarah, did you want to add anything else with your question?
No, that was, I mean, I hear you. And I'm not pro spray foam by any means. I think it's just, I think it's helpful.
Sure, no, it's a fair question.
And I guess there are times and places, I think, when spray foam you kind of have to. Even, you know, I was at a friend's house who she used rock wool across the board, like in between as like rigid board, but they did end up using, like, you know, in the cracks kind of thing, just, you know, a few places. So but they bias towards it. But trying to, I guess for me, my question was more about like digestible pieces that could be shared with the public that kind of help people make the you know, see this for themselves. So I guess I'll look up your article.
Well, the 475 building supplies really accessible.
Okay.
The red list stuff from the Living Building Challenge is very accessible, but the Healthy Building Network too, really sort of layperson's language. I mean, I'm not a building scientist. Very accessible, I thought. And then was it Bruce you had? Are you on our list, Bruce, next, or did I lose track? Where are we?
Yeah, I think it's Bruce, then Ting, then Don. Bruce, do you have a question?
Yeah, for sure. So, I mean, what's your advice to us here? You know, you're looking at this typical for us. There's 6, 8 of us at any given time. I think we represent a group that's probably more like about a dozen to 15 sort of active members. We're hoping to expand that, and this initiative that we're on right now of discussing buildings seems to be attracting more people. But anyway, we're a small group. We set out on this journey to try to learn what we can about this issue so that we can take action. What's the sweet spot for a group like us to focus on, in your opinion, in terms of like really making, you know, we put our shoulder to the wheel. Where can we have the most impact in getting that wheel to move?
Yeah, that's $1 million question. I can give some thoughts on that. I don't think there's an easy answer, but from a sort of political perspective, I mean, people worked hard in BC and they worked hard to get them to change things. So I think there's a question there, where do codes come from? Where there's a provincial code that everyone has to obey, but and getting this province provincial government to move is tough. But cities can do their own thing too, and the city of Toronto is trying to do something, and the period, I think, for input into the city code is passed, but you know, we all went on there like embodied carbon, and you know, and they talked to Chris Magwood, which was great. Part of it for me is educating folks. When people talk about greenhouse gases, they talk about electric cars and they talk about solar, and maybe they talk about their farming, and these are all super important things, but perhaps less sexy as the buildings we're in. And I think just talking about it is important. Potentially, you know, trying to partner with, if you know there's a nonprofit or community organization that's going to be doing, you know, like if there's a school or a community center, anybody that's going to be doing renovations, is to talk to them about that. Like, what does it mean to have buildings like this in our community? You know, it's hard as individual, like if you're either renters or homeowners. Yeah, I mean, this is the thing at the Fourth Pig. Like for us, like I'm happy to come and talk to you folks, because if at the end of the day, all we do is reno a bunch of buildings, like there's a development down the street from me that's going to burn more carbon than I've probably saved, you know, from all our buildings. What we care about is trying to change the conversation around carbon. And that's largely in institutional buildings and in the code. And so and I think a lot of nonprofits are very open to this, but they don't know. They're like, we're going to have an energy efficient building. And we're like, yeah, can you do this with some other materials and not use this? And people are beginning to move around the world on that. And so to me, that's kind of like, if you're in a specific geographical area, how can you communicate and support people in that specific geographical area, and maybe get your city councilor to sort of push on the building code. It might be too late though for the new Toronto standard, but that doesn't mean the Toronto standard won't be tweaked, right? Like I think the Toronto standards where we have hope here, because it's got to be better than, like there's going to be all these incentives and everything. The federal government claims they're going to be coming out with $2 billion in retrofit money, but we don't know what that means. It could be $2 billion, just for gigantic buildings, or it could go to homeowners. And if it goes to homeowners, and especially if what we're terrified of is that there's going to be a gigantic renovation project, and it's just going to be like, let's hose these buildings with spray foam and put vinyl everywhere. And then it's going to be a massive scramble to educate the public. Like, please don't, try it this way. I'm hoping it's all in, that if they go that route, that the incentives are there to do what I would call more true green building. Because as my colleague Melinda says, that's a generational mistake. Like, you will go by buildings like, that's a mistake that's going to last 50 years or 100 years. That's a 100-year mistake. And so I think we have an opportunity with the city. The city seems to be open. They declared a climate emergency. If you declared a climate emergency, your buildings are an emergency. And take it seriously, people. And that's why we were concerned in the meeting with them. There was definitely some openness to it. It just wasn't, what matters is what's written down. And they're like, consider and train people in embodied carbon. I'm like, well, considering it and training people in it isn't giving any points or tax breaks or incentives or anything, right? Like we're like, where is it? Show us the money. And maybe it's going to change. And I appreciated that they were consulting us and wanted to hear from us. So I'm hoping that it's going to change. But if it doesn't, people are going to have to really move. And if it does, then it's a great opportunity to educate people about why it's important. It's not as sexy as an electric car or solar panel. It's just a room, but it matters.
Yeah. And as you say, our energy costs are highly subsidized. So we're not, it's not the biggest thing in your mind in terms of your own personal issues. So it's got to be done in a way that that people can see it's affordable, beneficial to them, so that they're motivated to do it, and that they understand. And it's a complex issue, which is one of the reasons why we're doing all this educating ourselves, because we realize it's a complex issue. Can't really advocate on an issue like this if you don't really know what you're talking about. So that's what we're trying to get to a place where
sorry.
That's it.
I find when I talk to people that call us about potentially renovating their home or building their home, people, they genuinely care about their energy and they care about the planet, but probably their primary motivator is probably their family's health. I don't blame them for that, but that's, they're like, I want a building, I want material. They call us because they say, you folks don't use a lot of, things in the red list in your building. No, we don't. And then they know that by not using lots of stuff in the red list, well, it's already low embodied carbon, most likely, which is great. And so it's sort of like my partner used to sort of do a lot of stuff around organic milk 20 years ago. And she could talk about the regenerative soil, but people were really like, is there pesticides in this for my kids? No? Okay, I want it. They're glad that the farm was run the way it was run, but their primary motivator was kind of health of their family. Nothing wrong with that. So that's one way we sometimes talk about it with people. These are healthier buildings. And by being healthier buildings, they actually are pretty good for the planet. So in our thing, we say healthy for people, healthy for the planet.
Thanks.
I think Ting,
I'm happy to stay as long as you want, but I also don't want to feel like I'm overstayed my welcome. So.
Well, we had a couple more questions, so it depends on your time. And
no, I'm good to go. Still going.
Thank you so much. So Ting had a related question.
Thanks, Rabia. I mean, I feel like the previous answer covered it essentially. It was the same question, really. Like, what can we do? I think I kind of focused on the code, right? Is there anything we can do to convince the government to change the building code? But
you can convince the
essentially,
Rob Ford government to do anything. I'll take notes.
It sounds like a big focus is public education, right? Just making sure that people understand this and know what, like, the details, some of the details in this anyway, not necessarily all of them. Yeah, but I think you answered it. Yeah, thank you.
So I think it's Don then Lowell.
Okay.
Don, you're muted.
Don, you're muted.
Oh, it's just kind of a little thing. Our whole neighborhood has major termite problems, and
Mm.
so we're really restricted in the materials we can use. Wood products are not recommended. Um, I mean, they can be treated, but and even treated safely. But anyway, my specific question regarding insulation was just your thoughts about Roxel.
Oh, I
Because
love this question because I think Roxel really helps talk about the challenges of making decisions for people. Um, so Roxol used to be called rock wool, is a byproduct of stone mining, and it's done. There is some locally made stuff. By locally, I mean like an hour outside of Toronto. They make it, and it's got very high R value. It is fireproof because it's stone. It's easy to work with. It's a really good product. I would call it a light green product though, because in order to turn rock into a lighter insulation, you have to crank it up to 2,500 degrees Fahrenheit, just like you do to make a window. So there's a decent amount of embodied carbon in it, but not nearly as much as foam. And you can find these sorts of charts, and even on that embodied carbon calculator, he looks at different ones. And I speak as someone that's got, because I have an old house and many people have lived here and I'm not pulling out a lot of stuff. I was tucked in a weird corner of my basement the other day looking at a beam, and someone had spray foamed that years ago. So I still have that. I've got sheep's wool insulation. I've got denim insulation. I've tried out different things. I've got wood fiber board, which I love. It's, but it's kind of expensive. And I've got rock wool. Wood fiber board, and I've got blown in insulation. So blown in insulation and wood fiber board are by far the greenest insulation products I have in my house. And then going down there, I would say then you're getting kind of into rock salt. And then you're getting into sort of the polystyrenes and the foam. So there's a lot to be said for rock salt, and we do use it. We won't use a foam insulation on someone's wall, but we would use a rock salt. But we're always clear to our clients of what that means. The other thing it means is rock salt, like a lot of those things on the red list that are come from companies that are self-declaring. There's a movement, a real push for them to declare themselves what's in their products. And under pressure, they're doing it. Some of them are, and some of them, but that's where it comes from. Like someone's not just guessing; they know what's in these products. So Roxol hasn't done a declare label on their insulation, but they do happen to have a line of insulation that they call formaldehyde free. And I'm like, well, if you have a line that's called formaldehyde free, then what's this other line? Logic would tell me that it's got formaldehyde in it, and formaldehyde is a very common binder. Now, odds are that's insulation's outside your house. Odds are that it's a trace amount, and people have to make their own decisions about that. But I like that question because these are the complicated questions that people have to ask themselves. Because right now, the far, far, far greener choice is actually quite expensive, which is a wood fiber board. It's expensive because lumber has skyrocketed. The price of a 2x4 has doubled in the last 5 years. There's only one company in Canada that makes wood fiber board. It's in Quebec, and they don't even make it very thick, and it's not tongue and groove. So the best stuff is made in Europe. A new company is building it and going to be doing it in Maine, and it's a byproduct. So I know someone from Nova Scotia. She's an engineer. She's done over 100 passive houses, and she's like, we've got gigantic piles of wood waste, from the paper plants. It just gets burned, And she goes, and if I was in my 30s, I'd make a wood fiberboard company. Someone's going to make a wood fiberboard company in Canada that's mass scale, but it's not here. So we talk to our clients and like, we love wood fiberboard, can't afford it. We'll get Roxol. Roxol's got lower embodied carbon, but if you're trying to reach an embodied carbon kind of level for your house, then you can think, okay, well, I spent my kind of carbon budget a bit higher on this. Maybe I can save over here, So Roxol is not as bad as styrofoam, but it's not as good as some other things. But if you go all electric and have no gas coming in your house, then you're doing great.
Great, thank you. I think it was Lowell next, right?
Right. Yeah, I try to remember which question I wanted to ask. Oh my God. Um, the well, with Dawn, I'm just saying that would you think, Matt, would that work if they want to outboard insulate of the or whatever, use like even foam and but if you put like a metal cladding, then that would be the place to use metal cladding, right? To protect whatever. Um, would that solve the termite problem?
I solve the what problem?
The termite
Termites.
problem?
Oh, I'm not an expert on that. I'm not going to pretend to
Okay.
be one, but you can find good stuff online about that. And there's an amazing, there's a good whole set of books, um, a series. It's an American series, but it's actually edited by Chris Magwood in Peterborough, um, called what's the name of the series? I almost got it. Oh, here we go. It's New Society Publishers, and they've got books on rammed earth construction, on straw bale, and everything else. And they've got a really good book on just sort of building a green building, and they have some stuff in there, I'm pretty sure, on sort of pest stuff.
Yeah, that's a Vancouver publisher. They have all these other climate change books and even like
They're really good.
yeah, all these. Yes, my other quick question was to about the pot lights, but I think the solution, like talking to the last presenter, is to because the problem with the old pot lights, like in the 80s, they were like like 6 inches high and with the metal casing that each it's not sealed, right? Because there's maybe a heat build-up issue, but it takes up the space of all the insulation, right? And that's where the heat is leaking through. So like,
oh yeah,
yeah. And I thought maybe you could build a drywall box around it, but I think but then even that you may even have to leave a space because I don't know, but the thing to do I think now is to just maybe get rid of those and then invest in the LED surface mounted lights, right? Because they only stick out a couple inch, very small, and then so they're all that space could be filled with insulation again, right? Yes.
Yeah, sometimes you have to do some radical stuff. I mean, the city of Hamilton is they're taking a gigantic tower that was built in the 70s. They were supposed to build like 12 of these towers in the waterfront. They only built one, and the whole thing's falling apart. And they're going to rebuild the whole thing. But they said, all right, we're going to build it for senior housing, and we want it to be passive house. And so they hired a bunch of people, and there's actually a good video on this on Passabilities Canada's website. And they're like, here, we're going to give you all this, and you have to make it a passive house standard, or we're not going to build it anymore. So they're like, okay, one of the problems is, just like I was saying, they have these gigantic slabs that go out and make balconies. Well, each one of those is a problem because it's taking the heat from the inside to the outside. Their solution, they're cutting every one of them off.
I know, but I live
That's
in
pretty clever.
Yeah, I know, but that's the thing to do, like for energy efficiency. But there's something to be said about having a small balcony, and especially.
Oh, they're giving them little Juliets. And you can have a big balcony in a passive house, but you have to have a thermal break.
Yes,
and because this is government money, they don't have a lot of money.
But the thermal brick that I'm sorry, I just want to get this out. But the thermal brick that they would use is like a German patent technology, and it's like very expensive because it's the insulation and there's rebars right hanging. But I think what the problem is the protruding things that you're talking about. But if they are inside, like if there's like you know what I mean, if it's like notch inside the building surface, then I think those are the things that are okay because then it's not.
Yeah, then it's inside the envelope.
And inside. But the slab is not inside, but it's still, but it's not like protruding all the way. Like you know what I mean? Like, but having a small outside space in a condo, it's sometimes
you can do it, but you can't do it that way. But anyways.
Okay. All right. Thanks.
This is great. Thank you. Are there any other questions? I have a question slash comment. If not, does anybody else want to say anything? No, we're good. So, Matt, I know we've spoken a number of times about the Fourth Pig and the really great work that you guys do. and I met Mick as well.
All right.
Yeah, and he came and looked at our house. Actually, your comments about spray foam are really interesting to me, and that might be like a very concrete thing that our group can work on, like to sort of educate people locally about the dangers of spray foam. Um, because East York is a termite area, so there's a very like easy argument to be made uh, to people about why they should avoid spray foam, and also, but I had green savers into my house after doing an energy audit recently, and they said that they will only do spray foam in the basement, you know, and I sort of said, well, we're absolutely not interested in spray foam, and here are a whole bunch of reasons why. But I'm finding that the gap is like, I've found this for many years, that even as somebody who's willing to spend a little bit more than the cheapest possible price, it's very hard to find people who can do the work in the stages that we can afford.
Yeah, there's a
You know?
big gap. I think that there's a big training gap. There's an education gap. There's a materials and supply chain gap for sure.
Right.
There's no question about that. I mean, but it is interesting. Like when we were part of a group that had this thing called the Green Building Learning Zone. There's like 15 of us, builders and architects and stuff, at the Green Living Show a couple years ago. And John Tory came around, the mayor, and he was just glad handing everybody. And we're like, well, we're going to get 20 seconds with him. And so he said, well, what are you guys doing here? And we're like, well, one thing we're doing is trying to get people to not use spray foam. He said, oh, I've been hearing that from the firefighters.
Huh.
And because the firefighters are terrified of it. And we thought, that's an interesting idea. We should call up some firefighter unions and just say, hey, do you all want to go in on this together? And we just haven't gotten around to it. So, but it was interesting to me that the mayor brought that up to us.
That's really useful. Yeah, that could be something that like a small, you know, we're not experts, right? Like, so what role can we play? I think we could funnel, like you described, 2 resources that are out there against spray foam. So we can funnel things like that to the average person. Because that's something very concrete for a lay person to think through and understand.
Yeah, I think, yeah, I mean, and it's, you know, like Sarah was saying, there might be points where people think, well, geez, I really don't have any other options. And I'm not a building scientist, and I assume there are situations where it's going to be really, really difficult. But I would say the vast majority of them probably is addressable in other ways. And then people should know what they're getting when they do it. Here's the
Yes.
475's first link. You know, like I regretted putting mine in my office, and I regretted the way I took it out after reading this study. So I was like, well, if you're going to do it, know why you're doing it and be very careful about doing it. Just don't hose it around like it's cotton candy. So I just put I put a few links in here about stuff we've been talking about, but this one's on, reasons foam fails. They have 10 of them. And then we have a paper too, but it's not published or anything. It's just, but I do think that's a good one, especially if you can get if your local fire people are interested. I don't know who they were that spoke to the mayor, but.
This is fabulous. This is great. Yes, Bruce.
Well, I mean, that last comment makes me think about, you know, what if we said about, like, take a look at all the different issues that are touched here, like that, and Matt, you've mentioned people concerned about health, firefighters concerned about safety, you know, obviously people concerned about energy consumption, homeowners concerned about cost. Like if we start looking at all of that and identifying different groups who might have influence in those areas and build like a kind of a local coalition, you know, on this issue, and that might be a way for us to you know, have bigger impact, and a voice that gets heard. Because yeah, anyway, just an idea. But we're having a conversation next week. You'd be welcome to join us. I wanted to check, are you and Sarah both on our email list? Sarah, are you on the TEECC email list?
I don't think I am. I'm happy to be.
I'm not sure I'm on the email list. Yeah.
But
Yeah,
I just,
so can we make sure that,
if you use my Fourth Pig email, it'd be best, matt@fourthpig.org. And I just uploaded a PDF of our document. The folks of the Harvard, Rabia, you told me the Harvard folks, you've been in touch with them, but there's a Harvard neighbor, and we talked to them, and I shared this document with them. And apparently one person said, well, it makes it sound phone so evil. I said, well, that's fair. It does. Because it is.
I think we haven't been in touch with the Harvard folks, but the Pocket Change people have been.
Yeah, okay.
Right. Oh, that's great. Thank you for sharing that PDF. So if there aren't any other, are there any final follow-ups or questions or comments for Matt? Matt, I want to thank you so much. What a fantastic conversation, and really appreciated your time and your expertise, and your framing of it is really useful and interesting.
It was fun.
So
I enjoyed it. I appreciate you calling me in. I'm sorry, Rabia, that I was just like, that's got to be a different Rabia. She doesn't live in the East End. I didn't recognize your voice. It's embarrassing, but there we are.
There we are. I'm glad we've reconnected in this way.
Thank you, everybody. Take care.